Hi again, we're on to the last part of the assignment. So let's get through number 20. A solution of hydrochloric acid has a pH of 2.3. Find the following. For A, we need to look for POH, okay? And we are given pH 2.3. If you remember from the lesson, the total pH of the entire solution would consist of OPH and POH. The total value is 14. So you would want to use this equation, pH plus P. I'm going a little too fast here. All right, let me try again. pH plus POH equals 14. And we have 2.34 pH here. So you just plug that in, 2.3 plus POH equals 14, and POH will be 14 minus 2.3. Let me get my calculator so it'll be quicker. 14 minus 2.3, it will be 11.7. Oh, let me write it out so that you guys know what I'm talking about. 14 minus 2.3, the POH is 11.7. And that is your answer for A. Now on to B. Okay. For this part here, we are now looking for the concentration of the acid. And to find a concentration, remember you've got to use that equation, M for molarity, which is concentration, which is moles per liter. And it will be the inverse of the log. And remember, to find a pH, you would do the negative log times the concentration. But the inverse of log is 10 to the power of the pH. For this one, the B is for the acid, negative pH. Okay, so you just plug that into your calculator. To the negative, and the pH is already given to you up here, so it'll be negative 2.3. And you plug that into your calculator. Remember, it's got to be the inverse, and it's going to be that 10 to the power. There you go. 10 to the negative 2.3. Don't forget that negative. And your concentration comes out to be 0.0050. I did that because there are two sig figs there. And that is the concentration for your acid. And for C, we're looking for the concentration of the base. We are using the same equation, capital M for molarity, and the inverse log, 10 to the negative POH this time. And we already figured out OH, the POH over here, which is 11.7. So you just simply plug that in, 10 to the negative 11.7. Okay. And on the calculator, it is 1.9952623 times 10 to the negative 12. And we are doing two sig figs here. So this is 2.0 times 10 to the negative 12. And that is the concentration of your base right here. And since we're doing everything in two sig figs, let's just make this more accurate. 12 right there. Okay. And let's see if that also works to, if it's any close to this value here. Let's just try it out. Negative 12. Yes, it is. It's really close. I still have that times 10 to the negative 12 right there. Let's see. Where are we at? Oh, we are on to the last one now. 21. The POH of, okay, so it's going to be the same thing as number 20. For A, we are going to use that equation again, pH plus POH, which equals 14. And the pH is given to you, 9.3 plus POH equals 14. Your POH will then be equals to 14 minus 9.3. And then you put that into your calculator. 14 minus 9.3, 4.7. That is your POH, 4.7. Okay. And let's do B. The concentration for acid, we're going to use this equation, the inverse log 10 to the negative pH. And let's plug that in, 10 to the negative 9.3. How did I get 9.3? It's up here. And then the answer, the concentration for this, use the inverse log to the negative 9.3. And your answer comes to be 5.0 times 10 to the negative 10. Okay. That is the concentration for the acid. Now let's find the concentration for the base. Again, we are using that equation. Sorry about all the loud noise in the background. Today is trash pickup day. So it'll be the molarity, the inverse log to the negative POH. And let's plug that in, 10 to the negative, the POH, it was 4.7. 4.7. And plug that into your calculator. There you go. 7. Your answer is, let's do this at 2 sig figs here, 2.0 times 10 to the negative 10 molar. Okay, that is your answer. Okay, I hope that helps. I'll see you guys next time.